Okay, I'm here in 8.1 day 9 CAMI assignment. We're going to solve 4 systems of equations by graphing. Here in number 1, these directions apply to all problems in this assignment. Okay, so they're not going to be listed in every problem, but they will be the expectation for each problem. So first, show all work to put the equation in slope-intercept form if the equation is not already in slope-intercept form. Number 2, graph each line. Remember to begin with B and then move with M to form your line. And then third, find the point of intersection of the two lines because the point of intersection is the solution. So the ordered pair where the lines intersect is the solution to the system. We're not going to do number 1 in the video because these equations are already in slope-intercept form. And so you simply identify M, identify B, graph line 1, graph line 2, and then find the intersection of those lines. Okay, and that will be your solution. Remember, your solution is an ordered pair that consists of an x and a y value, and they're put in parentheses because parentheses go around ordered pairs. So we'll start with number 2 here. Okay, I have this system, and in this system I have equation 1 and equation 2. So label the top one equation 1, label the bottom one equation 2. As you can see, they are both not in slope-intercept form. I don't have y equals something, right? And so I need to put them both in slope-intercept form. So let's do that with the first equation. So I'll put a little 1 and circle it because this is my first equation. I'm just going to copy what this says right here. So I have negative 2x minus y equals 1. Okay, now I'm solving for y, right? That's slope-intercept form like we have been doing. And so I'm going to rewrite this in the slope-intercept form. Y is on the left side of the equal sign, and so this negative 2x needs to be put on the right side of the equal sign. And so I move it by undoing this subtraction by addition. So I add 2x, of course, to both sides so that these x terms cancel. Okay, so I have not y, this is not y, this is negative y. So I have negative y equal to, I'm going to put my x term first, so this is 2x. This is 2x, and that 1 is a positive 1, and so I put a plus 1. Now, is this slope-intercept form? Is this y equals something? You should say no, right? This is not y equals. This is negative y equals. Or you could say negative 1y, right? Because when the number is not written, it's assumed to be 1. But in this case, it's negative 1 because there's a negative sign. And so to solve for y, I divide every term in the entire equation by the number in front of y, by negative 1 in this case. So every term gets divided by negative 1. I show this step, of course, because I show every step of my work. I divide every term by negative 1 so that these negative 1's simplify to 1y. So I have y equals, okay, right here, I have 2 over negative 1. 2 divided by negative 1, that is negative 2, right? So I have negative 2. Now, what should I write next to it? What letter is this? What letter is that? That is an x. You must write an x in slope-intercept form. Okay, a lot of you have forgotten that in previous assignments that I have seen. So I put the x, okay? Then here you have 1 over negative 1. What is 1 divided by negative 1? Well, 1 divided by negative 1 is negative 1. So this right here is slope-intercept form for the first equation. And so because it's in slope-intercept form, the number in front of x, this number right here, that tells me m. That tells me the slope of this line. The slope of this line is negative 2. So up here, I will write negative 2. I'm going to go ahead and write it as a fraction so that when I go to graph this line, I know how to rise and run. So of course, negative 2 would be negative 2 over 1. So if the number before x is m, my slope, the constant term, that term that has no variable, that is my b, my y-intercept. That's where the line will cross the y-axis. And so b is going to be negative 1. Okay, now I'll do the same thing for equation 2 here. So I'll put a little 2 over here and circle it. Since equation 2 is not in slope-intercept form, I'm going to rewrite it into slope-intercept form. So I'm just copying down what this equation says. so that I can put it into slope-intercept form. Now, when looking at this equation, as you can see, my y term is not on the left side of the equal sign. It is on the right side of the equal sign. And so if it's on the right side of the equal sign, how about I just leave it there and move everything else to the other side? And so this positive 3 that is on the same side as my y term, move this term to the left side. So undo the addition by subtraction. So subtract 3 from both sides. That way these 3's will cancel, and you will have negative 3 minus 6x equals 3y. Okay, now I have 3y, but in slope-intercept form, I just want y. And so what number will I have to divide both sides by, or every term by, to get y equals something? Well, I look at this number in front of y. What number is that? That is a 3. And that is the number that I divide every term in the entire equation by to get the equation in slope-intercept form. So these 3's will simplify, and I'm going to go ahead and put y first, right? I could put y here, that would be fine, but normally y comes first in slope-intercept form, so I'm going to put y equals, okay? Now, right here, as you can see, I'm going to put my x term first, okay? I have negative 6 over 3. What is negative 6 divided by 3? That is negative 2. Don't forget your x term, right? This is negative 2x, okay? And then I'm going to put my constant term. My constant term are these numbers right here that have no variable. And here I have negative 3 over 3, or negative 3 divided by 3. Well, that is negative 1. Okay, so this right here is slope-intercept form. I have y equals negative 2x minus 1. Now, because it's in slope-intercept form, I can identify m and I can identify b. This is m right here because m is the number before x, and so that is negative 2. Again, I'm going to write this as a fraction so that I can use it for rise over run. This is negative 2 over 1. Notice how in the slope, I'm not writing negative 2x. The x is not part of the slope. The x helps you identify what the slope is. The m, the slope, is the number in front of x, but x is not part of the slope. Okay, my b is negative 1, the constant term, negative 1. And so as you might expect here, if the equations are exactly the same, when I go to graph them, I would expect them to be on top of each other, right? Notice how the slopes are the same. The slopes are negative 2. They're the same. And my b's are the same. My y-intercepts are the same. And so the equations of the line are exactly the same. And so you would expect these lines to be identical. And if they're identical lines, they're on top of each other. And if they are on top of each other, that means they intersect where? They intersect at every single point on the line. And so therefore, there would be an infinite amount of solutions. Okay, that's what we're going to expect when we go to graph it. So let's graph line 1. Line 1, I'm going to begin at B. B is at negative 1, and so that's where you'll put your dot, not on the x-axis. Remember, this is the x-axis, and this is the y-axis. I begin at B on the y-axis. So here's my y-axis. B is at negative 1. I'm going to put a dot right there at negative 1. That's where I will begin. Then I move with m. M is negative 2. Okay, so over here to the side, let me write negative 2 over 1. Okay, that is my slope. So the top number, remember the rise tells me to go up or down. And so if the top number is negative 2, that tells me to go down 2. The bottom number tells me to run. I run right if it's positive. I run left if it's negative. So because this is a positive 1, I run to the right. So from this B, I'm going to go down to right 1. Okay, let me change this thickness to an 8. And let's go from B down 2. So down 1, down 2, to the right 1. And make a dot. I could do that again. Down 2, right 1. Okay, now remember, going down and to the right is the same thing as going up and to the left, right? If I change the direction of both of these arrows, instead of going down, if I go up, and instead of going right, I go left, I'm going to be on the same exact line. So let me show you that. Okay, from B from B, if I go up 2, left 1, I will still be on the same line. So from B up 2, 1, 2, left 1, put a dot. From that point up 2, 1, 2, left 1, and put a dot. Okay, this is the line. Okay, so let's use the shape right here, the shape tool, line. Okay, and I'm going to connect. I'm going to click and drag to connect these dots right there. Okay, because this is a line, it extends forever in both directions. And so I will show that by putting arrows on the end of the line. Okay, and on the end of the line, I'm going to put a 1 and circle it because this is line 1. Line 1 comes from equation 1. Now, when we go to graph equation 2, are we going to be doing anything different? If B is -1 and M is -2, the line is going to look exactly the same. I would begin here, a -1, and go down 2, right 1, down 2, right 1, or up 2, left 1, up 2, left 1. And so not only is this line 1, this is in fact line 2 as well. So I'm going to put a 2 and circle it. So these lines are on top of each other. They are intersecting at every single point. Their slopes are the same. Their y-intercepts are the same. And so how many solutions are there? There are an infinite amount of solutions. And so what is the solution? You can draw the sideways 8 to tell me there are an infinite amount of solutions, or you could just write infinite. There are an infinite amount of solutions. Okay, number 3. Number 3 here, I have this system. And in this system, I have, let's call the top one equation 1 and the bottom one equation 2. First thing to look for is, are these equations in slope-intercept form? And you would say no, right? They're not. I don't have y equals something. I don't have y by itself on one side of the equal sign and every other term on the other side of the equal sign. And so if I don't have that, I need to get that by rewriting the equation into slope-intercept form. Okay, so let's do that with equation 1. So I'm going to put a little 1 and circle it for equation 1. And I'm just going to copy down what it says. 5x plus y equals 4. Okay, now I'm going to solve for y here. So like we have been doing all last week and part of the week before, y is on the left side of the equal sign. And so I'm going to move this x term to the right side by subtraction, right? I will subtract 5x from both sides so that these x terms cancel. And so I bring my y term down. This is y equals, of course, this is a positive y, right? So that's what I want. Y equals, put your x term first in slope-intercept form. So here's your x term. Your x term is a -5x, so -5x. And then put your constant term. Your constant term is a 4 or a positive 4. Okay, so this right here is slope-intercept form because I have y equals something with your x term first and then your constant. So now you can identify your m, your slope, is the number in front of x, and the number in front of x is not 5, it is -5. And so my slope here is -5. Again, I'm going to go ahead and write it as a fraction so that I can use it for rise over run when I go to graph my equation or graph the line. So -5/1 is slope. And then this number right here, my constant term, 4 is my b, my y-intercept. Okay, so let's go ahead and graph that one. So I'm going to begin at b. B is at 4. Remember, this is the x-axis. This is the y-axis. And b tells me where the line crosses the y-axis. So b is 4. Let's put our dot there. That's where we begin. I'm going to begin at 4 right there. Okay, that's where the line crosses the y-axis. Then I'm going to move with m. M is -5. Okay, so -5 and again over 1. So using rise over run, this tells me to go from B, I'm going to go down 5 and right 1. Down 5, right 1. Okay, so let's do that. From B, I'm going to go down 5. So 1, 2, 3, 4, 5 to the right 1 and put a dot. I could do that again if I wanted to, but I think I would be off the grid. So we only need 2 dots to make a line, so those 2 would be sufficient. So let's use shapes, line, click and drag. Didn't do a very good job there, so I'm going to do Control Z to undo. Click and drag. Okay, there we go. Arrows on the end of the line to show that it is a line that continues forever in both directions. Arrows on the end of the line. And I'll put a little 1 and circle it because that is line 1 that comes from equation 1. All right, now let's graph equation 2. Again, notice how equation 2 is not in slope-intercept form. So I'm going to rewrite it into slope-intercept form. So equation 2, I'm going to copy it down. X minus y equals 2. Okay, so my y term is on the left side of the equal sign. That means this x term needs to be put on the right side. So how am I going to move x to the other side? Well, that I would subtract x, right, to get these x terms to cancel. So I'm going to subtract x from both sides so that these cancel. And what's my y term? My y term is negative y. So I have negative y equals, put your x term first. Here's your x term. This is negative x, and then put your constant term. Your constant term is 2 or positive 2. Okay, this is not slope-intercept form yet because this is not y equals. This is negative y equals, or you could say negative 1y. And so to solve for y, I divide every term by the number in front of y. The number in front of y here is negative 1. And so every term in the equation gets divided by negative 1. Okay, that way these negative 1s simplify to just 1y. And so y equals what? Well, what is this right here? This right here is a negative 1 over negative 1. And what's negative 1 over negative 1? Positive 1, right? So I have positive 1x. Don't forget your x. So this is 1x. Okay, and then right here I have 2 over negative 1. 2 divided by negative 1, that is negative 2. Okay, so this is now in slope-intercept form because I have y equals with your x term first and then your constant. So let's identify m and b. This is m right here, the number in front of x. That's 1 or 1 over 1, right? And then b is this term. The constant term is negative 2. So b is negative 2. So if we go to graph this, I begin at b. I begin at negative 2, of course, on the y-axis. So that's where I will begin. I begin at negative 2 right here. Okay. Then how am I going to move? Well, m is 1, right, or 1 over 1. So my m is 1 over 1. This tells me to go up 1 and right 1. Up 1, right 1. Okay, so let's do that. From B, I go up 1, right 1. Up 1, right 1. And I could keep going. Okay, so let's use shapes, insert line, click and drag. Okay, then I put arrows on the end of the line to show that the line continues forever in both directions. And I'll put a little 2 and circle it to show that this is line 2 that comes from equation 2. Line 2 that comes from equation 2. So what's my solution? My solution is this point right here, okay? Because that's where the lines intersect. They have the same dot at that point right there. So what is that ordered pair? Well, from the origin, I would go right 1 and down 1 to get to the intersection. Right 1, down 1. And if I go right 1, down 1, that is right 1 is 1 and down 1 is negative 1. And of course, the ordered pair is put in parentheses. So the intersection is 1, negative 1. 1, negative 1. That is the solution to this system. Okay, last one here, number 4. Number 4, I have, again, a system that consists of 2 equations. I have equation 1 and equation 2. Looking at equation 1, is it in slope-intercept form? You should say no, right? So I need to get it in slope-intercept form. So let's copy this down, put a little 1 and circle it. It's x minus y equal 2. y is on the left side, so move this x term to the other side by subtraction so that those x terms cancel. This y term is negative y, so I bring it down, negative y equals, here's my x term is negative x, this is negative x, then the constant term is positive 2, so I'll put plus 2. Is this slope-intercept form yet? Should say no, right? This is negative y, or you could say negative 1y. And so to solve for y, we divide every term by the number in front of y, which is negative 1. Divide by negative 1. Divide by negative 1. These negative 1's simplify to 1y or simply y. So you have y equals, again, what's this? This is negative 1 over negative 1, which is positive 1. And don't forget your x term, so 1x. And then 2 divided by 1, that is negative 2. So we have y equals 1x minus 2. This is slope-intercept form, which means the number in front of x, that's our slope, 1 or 1 over 1. That's the slope. And then this term is b. b is at negative 2. Okay, let's graph that line. So I'm going to begin at b. b is at negative 2. Remember, this is our x-axis, and this is the y-axis. And so at negative 2, that's where I will begin, right there. Put a dot. Okay, then how will I move? I will move, my slope is 1, or 1 over 1. 1 over 1. And so this tells me from b to go up 1 and to the right 1. Up 1, right 1. So let's do that from b. If I go up 1, right 1, put a dot, up 1, right 1, up 1, right 1, up 1, right 1. Okay, then use shapes, insert line, click and drag, and arrows on the end of the line to show that the line continues forever in both directions. Okay, 1 and circle it. That's line 1 that comes from equation 1. All right, here's equation 2. Equation 2 is a special equation. It's x equal negative 2. So as you can see, there is no y in there. And remember, the trick that I've told you is that the top part of the x is a v, okay? And the word vertical starts with a v as well. And vertical means up and down, right? Vertical is up and down. So you need an up and down line at negative 2. You need an up and down line at negative 2. Okay, so let me go insert line here, insert line, and you can change the color of the line as well. So let's change this to maybe green. And here's negative 2. So I'm going to do my up and down line right here. Okay. And arrows on the end of the line to show that the line continues forever in both directions. And put a little 2 and circle it. This is line 2 that comes from equation 2, x equal negative 2. Now, as you can see, the way that we graphed line 1, there is no intersection. And so what I need to do is go back to line 1, and instead of going up 1, right 1, I need to go in the other direction to get how the line continues in this direction to see where the intersection occurs. So instead of going up 1, right 1, I could go down 1, left 1 from B. Okay, so from B, if I were to go down 1, left 1, there's a dot, down 1, left 1. And so there would be my intersection. Okay, if I extend this line, it would keep going and the intersection would occur right there. Okay. So what is this ordered pair right there? What is that ordered pair? That's where the lines intersect. And so from the origin, you would go left 1, 2. And if you go left 2, that is negative 2, comma. If you go left 2, that's negative 2. So 1, 2, and then down 1, 2, 3, 4. And so that is negative 4. Okay, so your solution is negative 2, negative 4.